All right, some EOM projectiles with angles. So, do a few of these from the quiz. Okay, so first some review. If we're going to do stuff in angles, we need to know how to decompose them. So that's, as it was shown by Galileo and Newton, things can be broken down into two dimensions, perpendicular to each other. We got on these horizontal motion at a constant velocity with what we're doing, and then free fall, the up and down and the side to side, vertical and horizontal. Okay, so we need to know those, breaking things down, and that means we use trig, where we have there, there, and there, angle, theta. So if we have this h for hypotenuse, let's say, then we get the x value of something and the y value, we can call it the horizontal and the vertical. And this, remember, is if it's set up like this, h cosine theta, h sine theta for x and y. Knowing your definitions of sine and cosine, remember, SOHCAHTOA, okay? So we use those to get our value and get the different components, because we deal with the horizontal and vertical separately, as Galileo and Newton showed. They are parts, components of one motion, but we can think of each one individually. The cause and effect here, and the cause and effect there. The causality here and the causality there. You know, motion here and the forces on it, motion here and the forces on it. Going side to side, we're doing something with no force acting, no acceleration. Up and down, we got the vertical, free fall. And so this part we use here. And this part we use here. Okay. You know, if your angles like that. As we'll see, we'll see this in some problems. So know your components. Then, if you have a different weird angle given, like, let's say, if in some situation you're given something like that, then you got to be careful, because then the y would be given by cosine and the x would be given by sine. So again, we got to know about the real world. We can't do this. We can't get lost in math or just blindly go through some formula to get things right. We got to see some concepts embedded in the broader world. Concepts, specific things do not exist in isolation. We need to train ourselves to put them in context of the real world. A very important thinking skill. So, try some of this with those preliminaries. So in our quiz, question 6 of 9, so this one and two more to do. So someone shot out of a cannon at a 40-degree angle, 40 degrees to the horizontal. That means you get the horizontal and you're 40 degrees above that. With a speed of 30 meters per second. Okay. And then you got to figure out how far away the person will land. If, like, the person and the net are the same, at the same height. It says the cannon, but the person would be up, or they're shot out of a cannon to be huge, and they'd be like, what, 6 feet, 10 feet? So, I just misspoke. So we got to know about that. Sometimes in something like this, it could be a trick question. Sometimes they just forgot to think about that. But where the person shot and the net are going to be the same height. Because, you know, the problem, we don't have how high the person is, so we can't figure it out. So they must not mean that we should use that. So, cool, 40 degrees, 30. So, we want to see, again, two parts. The distance it travels is horizontal. Let's do... we have the horizontal and the vertical. They can be separated causally. And so, how far does it travel? Well, we go a certain distance in a certain time. How long do we go? I don't know. We got to figure that out. That's determined by how long it's in the air. I don't know how far it's going to travel, but I know it's going to hit the ground. It's going to go up and come down and hit the ground. So this part we'll have to get later. This part we get first. Get this answer, plug it back into here. So 30 meters per second. 40, we want to get the components. The vertical and the horizontal. So we do 30 times sine 40, making sure we're in degree mode. 30 times cosine 40. So we got 30 cosine 40 mode. It's in radians. Degrees. Quit. Enter. So the x component of velocity is 30. So in this direction, the initial is 22.98, 30 cosine 40. So like the u here would be rounded to 23 meters per second. The up and down u would be 30 sine 40, call it 19 meters per second. Round it, you can do 19.3 if you want. So then that's one thing we're given in the up and down direction. So ignore this, look at this. We want to get the up and down. Vertical is that. We know acceleration, negative 9.8 meters per second squared. Because this is up and this is down. And we know we want to find the time. We can go, one thing we could do is get like Okay, it's symmetric. So we could get, if it starts at 19, when it gets up here, the up and down is 0. It would have stopped going up and started coming down. To go from up to down, you got to be at 0 at one point. So the vertical would have to have been at 0. So we could get the time to here and then double it, because this distance and this distance are equal. So get this time, multiply by 2. That's one way we can do this. I'll show you like that. So V0 and T we want to figure out. And then we do our 4 letters, figure out the equation, look at your formula or your book, figure out, oh, the one we use is V is U plus AT. And so 0 is 19 minus 9.8 T. Subtract 19, divide by 9.8. T is 1.94 seconds. And then we put that in over here. We double it. Remember, 1.90 here times 2. I was thinking about dinner. I'm hungry. And so I got distracted. Sorry. But I remembered. So 3.88. So this direction, S equals UT. Distance traveled is 23 times 3.84. So 23 times 3.84, enter 88, we'll round it, about 88 meters. Ta-da. Okay. Or, instead of doing it like that, we could have got the whole distance, the whole, like, time from the whole thing. So we get this, and we double it. Remember what you're doing. But you could get distracted by food, because, you know, it's a good thing, like I did. So, we could also do, we got U and A, and we got, maybe we couldn't do that, we don't have S. T, get the whole distance. Oh, maybe I could just do that. No, because that's the sideways thing. Up and down. Just the traveled. So the time, maybe that's it. We can go from 0 to 0. We got initial velocity, acceleration. Okay, I think, yeah, we could do like, we got that and that, but no, we don't know how far it travels, so we couldn't do that. We're trying to find time. So maybe it's something else. I'm distracted by food. My brain's suboptimal right now, so I'll just leave it like that method. Okay, good. So there's how we do that one. Now, then we do some of these others. Okay. So that was, yeah, I forgot to write the number up. That was number 6 of the ones we did. The one we just finished was 6 of 9. Done. Now I'm going to do number 9 of 9. So number 9 now from that quiz. Okay. A ball is thrown with initial velocity of 23.1 meters per second, 30-degree angle. We got to get a new angle. Okay, so that's a tough one. That's why it's here. So you can get an 8. I mean a 7 or a 6 instead of like a 4. So here we got 1. The ground point here. And we want to get the angle between the velocity and the horizontal line at P. And so when it starts out, it's at 30 degrees, the velocity vector. Degrees, 23.1 meters per second. And at P, we don't know the angle and we don't know the velocity. We got to figure out what's going on. So, we want to use a horizontal and vertical here in the facts. So remember, the horizontal velocity will stay the same throughout, but the vertical will change. So we're going to have the same bottom component of our triangle, but the vertical will change. And point P is 15 over 15 meters, 30, 23.1, Okay, cool. So we get this one and break it down, and the horizontal gets transferred over. Because remember, horizontal velocity doesn't change. This vector is going to have the same horizontal component as this is, but the up and down will change. So this one, we got 22.1. So we got Vx is 23.1 cosine 30 Vy 23.1 sine 30. Then we're going to have that as a half. So half of 23.1, that'll be 16.55 cosine of 30, 23.1 cosine 30. So about 20. And this will be like about 11.55. Okay, so I'll move this in over a little bit. Make it into a triangle. So you can draw a new triangle. Leave the stuff you had there if you want. You're taking notes, and draw a new triangle. You don't got to erase. It'd be good to keep that stuff and just go down your page. Maybe do the triangle down here if you want. But easy for me to erase here. Vx, Vy, 23.1, 30 degrees. And here, because there's no acceleration or force in this direction, as I said, it's the same. And we want to get the new angle. Yeah. So in this case, we'll get the up and down. We got this. We got this. So we're not going to get the magnitude of this, just the angle. But for this kind of stuff, two formulas. Once we have this and this, we use Pythagorean theorem to get that. So like, I'll just put V sub x squared plus V sub y squared is V squared. So this component plus this component is that. And then the angle will be like that, inverse tangent. So we're always doing something like that. The inverse tangent, the opposite over the adjacent, gives you the angle. Okay, so that's what we'll be doing. We got this. We use this for here. Now we're going to figure out the up and down. Once you get to there, what's the up and down velocity? So, let me see. We got there, it's over 15. So, we got over 15, go up, don't know what that is, got this. So it's beep bopping over there. If I get that, get the velocity, get that, get the height, go backwards. Let me see. I didn't know they'd be doing these things when I thought of it. Maybe I could, there'd be an easier way. But right now I'm thinking what we can do is get the no, we can just do, yeah, duh. So 15, okay. We got the horizontal speed. We got the distance traveled. If we write down our given, we're trying to figure stuff out. Like this would be our initial speed this way, doesn't change. So U is 20, S is 15, T is unknown, no acceleration. So can we get that? Well, yeah, there's a simple equation with only like 2 letters, you know, D equals VT, S equals UT, just 3 letters. So 15, 20t, t is 3/4 of a second. So it takes 3/4 of a second to get to there, because horizontally it rules. And then we see like how high it's going to be there, and then we can figure out the velocity. So 3/4 second, or we can just do that. We got the up and down velocity. So looking at this, up and down is 11.55. Acceleration, negative 9.8. Time, 0.75. V, we want to know, I don't know, what's the up and down thing? And so, because you know, I was thinking, we got the up and down. Gravity is going to slow it down. Oh, that's like gravity in a certain time, acceleration in a time. We can just use this stuff. So V, U plus A, T. But again, whoops, computer almost went dark screen. So this one is one that was harder. People wouldn't get it. But again, this is something that'll be like on an IB test to differentiate like 7 from 6 or something like that, or 6 and 7 from like 4. You got to do more than what we've done in class. You got to go beyond it, put things together to get an answer. So, welcome to the world of IB. So we got that, and then V 11.55 minus 9.8, 0.75. So, and if you round to 10, 10 times that is 7.5. 11 minus 7.5 is around 4. 11.55 minus 9.8 times 0.75. 4.15. So, that's the vertical. Distinguish the horizontal from the vertical. So 4.15. Then as I say, we get our angle like this. So it'd be, the angle is inverse tan of opposite over adjacent. So second inverse tangent, 4.15 divided by 20 under about 11.7 degrees. So it went from 30 to 11.7. So theta inverse tangent 4.15 over 20 is 11.7 degrees. Ta-da. Okay. There's one. Food for thought. Now, this other one. Okay. Now number 7 of 9. Okay, so throw a knife, apple thrown up, the knife gets in the apple. At what angle from the horizontal was the knife thrown? So we got apple 3 meters per second. Okay. So again, more complicated problem. Takes more analysis, put a few things together. Apple, 3 meters per second. The knife at some angle. 8 meters per second. And need to figure out the angle. So they're released at the same time. Knife let go of, apple let go of. At the same time, that's t equals 0. That goes up, that goes up. And it says they're both at the highest points of their trajectories. And here it says you can use 10 instead of 9.8 for acceleration to gravity. Gravity, 10 meters per second squared instead of 9.8. All right, so we'll do 8, 3, the components. So here's thrown up 3. So this, the Vx is 8 cosine theta. Vy 8 sine theta. And then gravity will slow that down there. Let me see, with 3, that goes up, the apple goes up, and it stops. So here, how long will it be in the air? How high does it go? Let's see what we will need for the other parts. So for this, we got initial velocity is 3. When it gets to the top, it's 0. Acceleration, they say we can use -10. T, we don't know. And then we can do V, as we see, U plus AT. 0 is 3 minus 10T. T is 0.3 of a second, 0.3. And I wonder, I don't know if we need how high it goes. While I'm here, let's see, like, we could also do this and this and this with the S, like, I guess I can squeeze it in. V squared, U squared plus 2AS. So 0 squared, 3 squared plus 20S, or negative, because acceleration is negative, and it's going to fit the signs. So 9/20, that's 45/100, so 0.45. So 9/20 multiplied by 5 top and bottom, 45/100, 0.45 meters. Okay, then over here we got 8 cosine theta, and it goes until 0. So if we put that in, maybe I could solve for theta. Let me see. If we knew, initially it's like that. So U 8 cosine theta, V is 0, because it says they're both at the highest point. They're at the highest points of their trajectory, so the upward velocity would be 0 also. Then A is -9.8, T 0.3, so we can just use that. I don't need to use that, I guess. And so, which equation, then zero 8 cosine theta minus 9.8 times 0.3. Then multiply, move it over, 9.8 times 0.3, what, 27? Oh, they said we could use 10. Use 10. 10, so of course it's 3. So 8 cosine theta is 3. Cosine theta is 3/8. It's still showing up, yeah. And then theta, inverse cosine of 3/8. So, yeah, so here, cool, on the screen, inverse cosine, oops, inverse cosine, -67 degrees, 68, round it. So 68 degrees. That's what it is. And that was our last one. Yep. Oh, but they got 22, the opposite. Oh, sine. Oh, yeah. Okay, yeah, I should use sine. Better look. Okay, sorry. Yeah, because this is horizontal and that's vertical. I was thinking about the vertical, but then I used the horizontal accidentally. So I was hoping I was done and I could have dinner. So blame it on food again. Food. The cause is food. Food causes mistakes. At least when you're hungry. Okay, sorry about that. There. Yeah, because again, I was hasty. I was thinking about I'd be about done and I could eat. And so I failed. Obviously, I said the up and down, and it's obviously that, but then I used that accidentally. You know, because initial, when it goes up, the velocity is initial, the final is 0, but horizontally it's never 0. But I didn't think about that, which I usually do, because I was thinking about food today. So that should have led me, if I was more awake, I would have got it right in the first place, or even here, I would have remembered that it would be sine. But I don't know, I wasn't thinking about it. I was hoping I was done. Wishful thinking. So there. So sine theta, and then 0.3, and that would work out. All right, so theta is 22 degrees. So I'm using the up and down. It starts, it's going at a velocity, it stops, and then it comes back down. Because when it's at its highest point in its trajectory, that's where it hits the apple. Remember, it's not going up or down here. It goes up, it has an upward velocity, then it stops and has a downward velocity. To go from upward to downward, you got to go through 0. All right, so those are the problems in the quiz. Enjoy. And I'm going to go eat food now.